So section 1.1 is all about graphing. And so we're going to start by talking about the Cartesian coordinate system or the rectangular coordinate system. And so as you all should know, the coordinate plane is divided up based on both the x and the y-axis. And they divide this plane into 4 parts. And so we have quadrant 1 in the top right, quadrant 2 in the top left, quadrant 3 in the bottom left, and then back around to quadrant 4 in the bottom right. Okay, and so we know that everything in quadrant 1, both the x and the y values are positive. In quadrant 2, the x's are negative, but the y's are positive. In quadrant 3, both negative. And in quadrant 4, the x's are positive and the y's are negative. And so we should be able to plot points in any one of these quadrants in order to sketch our graphs, which is the main goal of this section. And so we know that the graph of an equation in 2 variables is a set of points where the coordinates satisfy the equation. So one method that we can use for plotting this is what we call the point plotting method. And so in order to do that, we're given an equation and asked to graph it. And so we choose values for x, and we plug them in, and we generate ordered pairs. So in this case, we're going to start with -3 and run down to +3. To do the other page with +3. But we're plugging in 4 minus -3, which gives us 7. So we have the ordered pair -3, 7. Then we have 4 minus -2, which generates a 6. 4 minus -1, which of course gives us 5. 4 minus 0 is 4. 4 minus 1 is 3. Oops. 4 minus 2, of course, is 2. And then finally, when x is 3, we have 4 minus 3, or 3, 1. And so I start plotting my points, including those on the other page. And so we have -3, 7, -2, 6, -1, 5, 0, 4, 1, 3, 2, 2, and 3, 1. And once I connect those points, I have my graph for that particular equation. Okay, and we'll do the same thing here. We're going to start with -4 and end with 2, and then we'll plot these points for this absolute value equation. So here are the ordered pairs for this particular problem, and we're going to graph them now on the next page. All right, so I'm plotting the points I had described in the previous table. So we have -4, 3. All right, so we're going to start with -4, 3, -3, 2, -2, 1, -1, 0, 0, 1, 1, 2, and 2, 3. And now when we have an absolute value graph, our graph is more like a V shape instead of the U like the parabola. Okay, and so this is the graph of that previous table. Now, the next thing we need to talk about is our intercepts. So an x-intercept is where the graph either crosses or touches the x-axis. And so on the same note, the y-intercept is where the graph either crosses or touches the y-axis. All right, and so now we want to be able to identify the x and y intercepts. And so here are some graphs, and we're going to look at the x and y intercepts on these graphs. So for A, the x-intercept happens at -3, 0, and the y-intercept happens at 0, 5. Okay, on B, there is no x-intercept, and the y-intercept happens at 0, 4. And for C, my x-intercept happens at 0, 0, and the y-intercept is also at 0, 0. And now you should notice that x-intercepts are the point where y is equal to 0, and the y-intercepts are the point where x is equal to 0. And so we can have various numbers of intercepts depending on the graph. Okay, and so you could have no x-intercept and one y-intercept, or we could have one x and no y, no intercepts, 1 and 3. We can have really any combination of intercepts for both the x and the y-axis. All right, and then what we want to do is we want to be able to use linear graphs or line graphs in order to help us illustrate some trends over time. And so here's an example of the divorce rates comparing couples who married in the teens and couples who married later on. And so it's based on the wife's age. And so you have one line, which is this like purplish line for when the wife is under 18, and then the blue line for when the wife is over 18. And they've given us two models, which are equations, that display these two, or that are approximating the data for these two graphs. And so A says, use the appropriate formula from above to determine the percentage of marriages ending in divorce after 15 years when the wife is under 18, at the time of marriage. So under 18 means I'm using this equation, and I'm told that n is the number of years after marriage. And so that should be D equals 4 times 15 plus 5. And so that should give me 65% for when the wife is under 18. Now we're going to use the graph then to help us approximate or to find the actual value for the divorce rate after 15 years when the wife is under 18. So if I come up here, 15 years with the wife being under 18 puts me at 60%. All right, and then the mathematical model overestimates the actual percentage by 5%.